I have to drag a cylinder through a liquid here. Now, this is filled up in a container, a vessel. How much of force will apply on this cylinder? So let the cylinder is of height h, radius r. There's a viscous oil or honey or any other thing. There's a container. Let me show that. This everything is the viscous layer. Also viscous liquid. And I'm going to drag the cylinder. Tell me like how much of power I should exert on the rope, on the cylinder to drag up with constant velocity. Able to understand now? Small diagrams. Huh? No. So what is the force, the tension force, what I apply, the tension will act here. How the viscous drag, where do it act? Everywhere on the curved surface. Is it okay, fine? This is, so then I had to move with a constant velocity. So what is the external power should be equal to F external into V. What is F external should be equal to viscous drag into V. Now what is the viscous drag? Eta, surface area 2 pi R L, velocity V into this is V. What shall I write? What shall I write perpendicular distance here? That perpendicular distance should be R by 2. I am just giving some information. So what is this vessel? This vessel, what happen will have how much of uh, the radius of this? 3R by 2. Then at what distance the surface of cylinder will be the surface of the from the inner wall of the vessel will be at a distance R by 2 or 3R by 2? R by 2 it will be. So therefore this has to be written R by 2. Able to understand? See, if you are getting confusion, take help of diagram. Nothing is there. It will be like this. No? Then how the cylinder will be like this. Tell me like what can be this distance? R by 2. So you look at the every point of the cylinder, surface of cylinder will be at a distance R by 2 from the vessel. This is the vessel. This is the cylinder. I think we have to be a little bit careful. Huh? And this is a liquid. Fine. So do make observation to plane diagrams, 3D diagrams. You can better analyze it. Okay, now let's take the, after this, I'll go for Stokes' law. Let me introduce another one more topic called as Stokes' law. So what you have to give priority here afterwards, area of contact of the solid with the viscous liquid, and that perpendicular distance has to be noted down. Fine. Like this, what's happening here? The different shaped bodies, what happen when you drag through a liquid, viscous liquid, what happen? The area of contact matters a lot. See, earlier it was very simple. What I brought it, you can see that one. What is the area of contact? square area. Here pi r square. Here L square. Now here LB. For cylinder, what happened? Surface area of a cylinder. That has to be substituted. So what is this quantity? This is the surface area of a cylinder. What is 2 pi RL? 2 pi RL. So definitely it's not that easier. We should be very careful about like where all the liquid is in contact with the surface of a solid. That surface area has to be kept in the formula here. Eta A dV. And what is this R by 2? Perpendicular distance of the solid surface with the vessel have to be calculated, that one. So different problems, what happen, the distance R by 2, this 2 pi RL, based on the body, based on the situations, it will be different. Okay, let's go for, let me use one more. Stokes law. We'll discuss on this also. Like this. So what, now I'll give one, we'll have small discussion. What is that? So this is a cylindrical container. I'm going to drop, I'm going to pull a so there's a string. I'm asking you to pull this with a constant speed. So what is this? This is like a spear. There's a vessel kept on ground. There's everywhere liquid is present here. So what is inside? Inside is a viscous oil. Okay, now I'll ask question. So now, what is the external force I should pull up? So there's a string. Okay, let me put everything in clear now. Anybody, can you tell it? Okay, eta, no problem. What is the area there? Sir, what is the area? Area of a surface of a sphere, how much? 4 pi r square. What is the velocity v? So what is the viscous drag? S, in fact, viscous drag and weight will act. So what is the external force I should apply? Viscous drag plus mg. What is the viscous drag? Eta 4 pi r square v. Till here, no problem. But what to write here? What shall I write? You look at this layer will be at a certain distance. What about this layer, certain distance, this layer? The different layers here will be at different distance. No, that to happen, you should assume a ring here. This particular ring, elemental ring, will be at some distance. This particular elemental ring will be at distance. So what's happening? The different points of a sphere are at different distance from the wall of a vessel. So what to write in the denominator? You have to ask a best question to yourself. So what is the biggest problem here? So shall I put like 1, 2? What is the distance of 0.1 from the wall of a vessel and 0.2? So they are different, no? So what shall I write? I don't have anything. This has to be question mark. It's not some quantity. We don't know this. This has to be determined. So it's like this, what happened? Different shaped objects, when you drag through a viscous liquid, what is the biggest headache for you? Sometimes area you cannot find out. Sometimes this will be problematic. This will be problematic. And the next, we don't know this. Able to understand? We don't know this. We are not very sure. So it's not that easy on this chapter. If you're trying to drag the different shaped objects through a viscous liquid, no, sometimes the area or sometimes this one will be very problematic here. So to overcome for spherical body, so what is telling is a Stokes law is brought here. This particular thing is what I'm going to address. Weight of the cylinder. Okay, you want weight of the cylinder. Huh? It can be lightweight or because I wanted to, okay, light cylinder, I'll put it. Even buoyancy will come.
Yes, sir.
Okay, I'll do one thing. I'll introduce Alma so that you should not get confused. Let me introduce all. This is about the only viscous drag will calculate it. So what is the external power? Now F external should be equal to, I'll bring everything now. So T plus FB is equal to FV plus mg. Viscous drag we know 2 pi eta RL V by this R will get cancelled out. This is a viscous drag, then weight of the cylinder. This is mg, there's no problem. Now what is the buoyant force? Density of the liquid rho L. So this is what the tension is, nothing but F external. So what is the power now? I'll include that also. Most of the cases, the buoyant force, all the weight will also be negligible. We'll be focusing more on this. But anyway, like it depends on the numerical. Let's not generalize anything. If you ask us to neglect buoyant force, we'll neglect. If you ask us to neglect weight, well, if it doesn't say anything, we should consider all. So what is the external power? Multiply this quantity with V. That is what you should pull up here. So we are very good in buoyancy and weight. The biggest problem is the viscous drag. So here, this is what happens here. So here also what you have to bring? Minus FB. So FB, there is no problem. Am I right? Rho L. I'll bring everything because. Yeah. Okay, now Stokes law, what happened? He has proposed like this. So if you have a liquid